Alright guys, welcome to the channel. You probably know what this is or you wouldn't have clicked on the video, so there are all the nice juicy little details. Alright, so what's going to happen? I'm going to tear this down and I am going to do a technical design review. And you might say, well, what the heck qualifies you to do that? And aside from my massive YouTube subscriber base, internet, Reddit, credibility things, I'm also a professional product design engineer. Designed multiple products very similar to this, electromechanical with batteries, some of them. So I've never designed a tool, but I've designed products that basically use the same manufacturing processes and combine the same types of technologies. So that's one of the reasons I do this, is because I might learn something from opening this up, a way to make the products that I design better. So if that sounds interesting to you, then come along for the ride. Alright, so as usual, I will start from the outside and work my way in, just commenting on what I can see. So we got combination of different materials. We got definitely metal, and then we've got hard plastic and rubber hard plastic. So the texture, the grippiness of this is among the best I've felt straight out of the box. Again, learned my lesson on the Milwaukee that it was kind of slippery right out of the box, but user feedback told me that that was just because it was brand new and it quickly gets very nice and grippy. So this could do the opposite, but just telling you guys what I see. So nice matte finish, really nice looking label. You can tell that Hercules and Harbor Freight trying to imitate the higher end products, but we'll see once we get inside if that's really the case. So all right, so very similar to most electromechanical hand tools. We have the handle and main structural body is comprised of a plastic injection molded part that has been bi-injected with a rubber overmold to give structure where you need structure, hard, rigid structure where you need structure, and then nice, soft, grippy, high friction surface for comfort and grip of the user. So I would expect this to be a glass-filled nylon, just because that is so common among these tools, and that is correct. The PA stands for polyamide, which is the chemical name for nylon, and specifically nylon 6, which is the second most common polymer of nylon, and it has GF30, which is 30% glass filled, and then TPE is the overmold. That's a type of injection moldable rubber. So polyamide 6, nylon 6, is a more colorable aesthetic version of the more common nylon 6.6. So this part is really stiff. Of course, it is basically half a tube, and that is a really good shape to start with, especially when you're putting it together with the other half to form a whole tube. A tube is a really rigid shape and an efficient use of material to get that rigidity. And it makes sense. This handle is going to have more torque on it than a normal drill, I would imagine, because part of what this tool is that you don't actually have to be pressing the button to use it. It will ratchet just by just like a normal ratchet would. So you can use it by hand or to apply more torque, than the motor can handle. I don't know how much torque that this mechanism up here can take, relative to what the motor can produce. So don't take my word for it about just going to town, trying to take something off that's 80 foot-pounds. But I know that's one way that it's intended to be used is manually. So, but yeah, bunch of all the details that you can put in injection molding is one of the reasons why it's such a highly used manufacturing process. Just you can, trying to put that level of detail in most other processes is kind of difficult. Even casting, metal casting, it's kind of hard to get it to flow into tall, thin regions like that. Whereas plastic, it's under 10,000 psi pressure, just to give a rough idea, and so it'll force it to go up in the various places, so you can have a lot of detail and purpose built into one single part, instead of having to clip in different parts that are for different things. So all right, little handle here, which is another injection molded part with more of a orange peel finish on it, and again that one is also nylon 6 30% glass filled. So all right, start down here. So this is also an injection molded piece, and what do you know, it's nylon 6 also 30%, and I can't tell if those contacts have been molded in or if they were pressed in. It looks like they're undercut. Yeah, so it looks like they've probably been molded in. So similar to how this rubber gets over molded over the hard plastic, this hard plastic got over molded over these metal contacts. So they put the contacts in the mold and then shoot the material around them, and it makes a part that's really easy to mount and has the two different properties that it needs to have. Cheap plastic housing, metal contacts for electricity, and it didn't require a lot of labor. You didn't have to have somebody sitting there, with using tiny little motor skills for 8 hours a day or 14 hours a day in the slave labor countries, to assemble these. You just have to set them in the mold, and then the injection molding process does the work. So that is a really beefy trigger assembly compared to what I've seen on other tools, and that's also a really tiny circuit board for what I've seen on other tools that have a similar battery size. So there's also a circuit board down in there, but that's normally just the battery controller circuit board. So not sure why this circuit board can be so small for what it's doing. Part of it probably is this looks like a brushed, yep, it's definitely a brushed motor. You can see the brushes right down in there. So that does take less circuitry, takes less complicated circuitry to run a brushed motor than it does a brushless. So okay. Ooh, that is interesting. Well, I have never ever seen a triangular coupler like that. I've seen rubber couplers be triangular on drive shafts, but that is really cool looking. This is no doubt a planetary reduction, which is the most common reduction in electromechanical power tools. Well, so in a planetary gear reduction, you have the sun gear right there in the middle, the planets, the little gears that rotate around, and the ring gear, and this is called the carrier that connects the planets together. So that's probably given a reduction of between 10 and 20 to 1, which is really good for how tiny it is, which is why planetary reductions are so common, is because they're strong, because you can basically put as many gears as you can fit, planet gears as you can fit in there, and to a certain point it gets stronger every time you add one. So within the same size, the same amount of thickness and diameter, you can have a lot of strength and also a lot of reduction in the same in a small space, which is why they're used on car transmissions, everything from car transmissions to hand tools. So all right, so something that is kind of interesting to me from a mechanical design aspect is all the screws that they put in here. It's right, so there's a lot of leverage right here. You're going to be doing that if you're using it manually, and also resisting the torque that the motor is producing, just by holding it there. And so, see, they put a nice, kind of half dovetail in there and then when the other side clamps down on it, that's gonna be really hard to get out of there. And they put all the screws, but like half the screws. There's 1, 2, 3, 4, 5, 6. So, and there's just four up here. So a little less than 50% of the screws all focused right here to keep this mechanical assembly from coming apart due to prying on it. And that's exactly what I would have expected. If they made this out of metal, it'll only be as weak as its connection point, because the plastic is in a tube shape, and then this is a really heavy metal circular part of it, and so it's obvious that the weak point would be in the connection between the two things. And they put some cool design features to make sure that they are mechanically coupled very rigidly. And not only that, so they stuffed the motor up in there and had it screw through into the motor. And so now not only do you have these features in the plastic counteracting the torque, you also have the motor, and it's sitting it's touching these ribs right here, And so now the whole motor is like a support bar for the connection between these two pieces. So that's really cool. That's what I call, conceptual design. That, how you had to have that kind of planned out, how all these 3 or 4 different components were going to connect to one another in such a way that maximized their interaction with each other to perform the function that you want, which in this case is strength and durability between all these parts. So that just makes me feel good inside. If I had designed that, I'd be looking at that and thinking to myself, like, man, you did a good job. So good job, Hercules. Or I don't know if this is a knockoff of other brands did it this way before. I don't know. I haven't seen enough of them to know, but it's pretty cool to me. So looks like that is, aha. All right. Looky there. So that is the drive shaft, and that is a beefy some gun right there. That is just a solid steel. Why is my camera not focusing? There we go. Well, that is just a solid steel shaft. No playing around. And for your guys' information, it looks like it's a roughly 1/2 inch, but could be a millimeter equivalent. Yeah, this is a millimeter, which is, yep. So it is dead nuts 1/2 inch, or dead nuts as far as I'm concerned. Plus or minus 1 is pretty dead nuts in my book. All right, and so it has an eccentric or non-concentric shaft that is no doubt critical to the ratcheting function that goes on. So let's see. Yeah, so I'm gonna spin this and see if I can. Yep. So you can see it moving around in there. See, there it is. Oh, if I can get it to focus on that. There it is. All right, and that is well lubricated, as you can see. Icky. It's a technical term. And very nice needle bearings in there. I would have thought that, if they were going to cheap out, they would have put a plain bearing there, plain bronze bearing, and they have not. The needle bearings are not cheap, and so they went to that expense. I wonder if there's another set down in there. All right. Yep, so there is a needle bearing at either end of that, and otherwise a pretty simple mechanism. That slides back and forth like that as this goes around, because this stays center. that stays center and it slides. So it allows for left and right action because it only needs to ratchet in this direction. So it doesn't want to let it move that direction. So it slides back and forth. And so the directions where it can't slide, it forces it to move like that. And so the ratcheting mechanism just goes like that, just on a circle. I think beard and hair trimmers work on a much smaller scale and lighter duty scale of this same concept. So that does not look like it can tolerate a whole lot of torque. But that's what kind of the price you pay for being able to get into tight spaces, being able to send. You're limited by the narrow drivetrain and the size of the mechanism, because if they made it big and beefy like something this size, then you wouldn't be able to fit it into the tiny spaces that you can fit this product into, which is kind of the whole point. So these are there's ball bearings. I'm gonna have to figure out where they go. That's the selector, and then there's the mechanism, that the ratcheting teeth that made up into those gears right there. So that's really cool. It's spring loaded, so it can go back one way, and then the angle that it's at means that it can, when it turns this way, the teeth can slip, but when it tries to go that way, depending on which direction you have it set to, oh yeah, here we go, there. So that will slip that way and then lock in that direction, and then when you switch it, that will slip that way but lock in that direction. So that's probably the same exact mechanism that is on manual ratchets also, although I've never taken one apart, so I can't tell you for sure. Well, I definitely learned a lot taking this apart. Hope you guys did as well. I can't really tell you how this is constructed relative to other brands because I've never taken them apart, but I'm fairly impressed with what I've seen. I have taken apart other tools and I know where they cut corners, and this didn't seem like it did. And again, a telltale sign for me is the expensive needle bearings that are at both ends of here. They could have made those plain and you probably would have never noticed it until the tool started wearing out and getting sloppy, years from now. So all right, so quickly my thoughts on using the actual product. Like you saw in the beginning of the video, I used it to replace my CV axles, and it will not break loose any bolts of any substantial size or torque. You're going to have to do that with either an impact wrench or a ratchet by hand. But after that, not having to ratchet out every single thread of a bolt that is a tight thread or has some corrosion, one that you can't get out with your fingers, it was worth every penny. I had 12 bolts per CV axle to take out in tight spaces, and it was a royal pain in the neck when I had to do that by hand with a ratchet. So even though I still had to use the ratchet, I just had to break it loose like one to two turns, and then the wireless ratchet could take over, and that's both on taking them out and putting them back in. So that was the whole reason I got it, and it did it. I didn't expect it to be able to break loose 40, 50, 60 foot-pound bolts anyway, and it definitely can. It only really small bolts, probably smaller than a 1/4 inch, and even then probably not, depending on what they're torqued to. So just wanted to give you guys that insight from me using it a couple of times, and enjoy this clip of me putting it back together. All right, guys, well, that about wraps up the design review for the Hercules ratcheting wrench from Harbor Freight. Leave me a comment down below if you didn't like something about the content, or you did, or you had a question maybe that I didn't cover, plop it down below. If you like the content, give me a like. If you really liked it, give me a subscribe. And if you super duper liked it, then run a Goodyear blimp and advertise for me on the Super Bowl, or just do the like thingy. Whatever works for you. All right, I'll see you guys next time.